Hello students, the question says a source of potential difference V is connected to the combination of two identical capacitors as shown in the figure. So this is V is connected to two capacitors. When key K is closed, so this is a key which works like a switch. The total energy stored across the combination is E1. Now key K is opened and dielectric of dielectric constant phi is introduced between the plates of the capacitors. Okay. The total energy stored across the combination is now E2, then E1 by E2 is. So let us study what is the key concept in solving the problem. The key concept to solving the problem is, that is, first adding dielectric. The first key concept is adding dielectric between plates of capacitor when connected with a source. What do you mean by this? Okay, in this concept, what happens is that there will be a capacitor and it will have a voltage V. Its capacitance would be, let me call this as C naught, and it would be voltage V. Now what we will do is, we will take a dielectric and we literally place the dielectric between the plates of the capacitor in this way. So what happens when you place this dielectric between the plates of the capacitor? We have to comment on that. So let us see what happens when I place this dielectric between the plates of the capacitor. We know, since it is connected to a source, its voltage must remain constant. So in this case, what remains constant if somebody asks? Voltage remains constant. Now I can no longer call this as C. Let me call this as new capacitance, some C new. Okay. So the C new would become, we know the formula would become, here the formula would be epsilon naught A by D. Here, since I add this dielectric of dielectric constant K, so it would become K into epsilon naught A by D. So we can say C new would be K times the old one, that is C naught. So this would be the first one. Next, we know voltage remains constant. What does it mean? So if originally, what is the new voltage? New voltage is still V only, whatever is the old one. Next, from this, what is the new energy? The new energy in this case is half C into V square. So C new into V square. So K C naught into V square. If you notice it, its new energy would be K times the old energy. So K into whatever is the old energy. So old one would be E naught is equals to half C naught into V square. We got K times of that. So K times the E naught. Okay. And the last one is charge Q. Q equal to C into V. So you'll get charge Q is equals to, again, K into old one. Okay. So K into Q. You can see in this first case, the key formulas are that all of them have increased by K times. So whenever you see this case where you add something, so let me take this to the next page. So whenever we consider this case, so you should understand a key point, that is adding dielectric between the plates of the capacitor. What are the formulae we get? The first conclusion you will make is V or V2 is equals to, it will remain the same thing, original one. Okay. Charge Q2 will increase it by K times. Next, final capacitance would become K times the original one. At the same time, final energy also would become K times the original energy. You have to remember all these four things. Next, what happens if you do the same thing, adding dielectric between plates of capacitor in an isolated circuit. In an isolated circuit. Suppose if you take an isolated circuit means it will not be connected to anything. So in an isolated circuit, so basically there is no battery. So here we have a capacitance C and its charge is Q. It should be already be charged. Okay, that is very important. Now what I will do is I will take something and I will let us say its original voltage was V. Now I disconnected it from a battery. Originally it was connected to battery. Now what I will do is first step I will disconnect the battery. As you can see, I did not draw any battery here. Then I will take a dielectric and literally we place this dielectric between the plates of the capacitor. We literally place this dielectric in an isolated system. Since in an isolated system, where will this charge escape? This charge cannot escape anywhere. So in this case, we can say charge is constant. Since charge is constant, I can say Q2 equals to Q. We know what happens to capacitance. Capacitance C2 would be K epsilon naught A by D. So it would become Kc. This is also fine. Then what about V2? We know V2 would be Q2 by C2. Q2 remained Q only. C2 became K into C. What is V? V was Q by C. But V2 we got Q by Kc. So you'll get V2 equals to 1 by K times the original one. As you can see, voltage decreases by K. Even though these two in every time the capacitance increases, here voltage decreases by K. If you solve it, energy equals to, you can write originally the energy was half CV square. Finally, what is the energy? Half C value is Kc into V square is V square by K square. So you will get K, we can cancel. You will get half CV square by K. So indirectly it is E by K. So these are the new set of formulae. Finally, what can I conclude in this case? Again, I will take it to the next page and we'll see what can we conclude from this. So from this, I can conclude that for the given case, what would be same? First, Q2 would be equal to Q. So it would same. Next, capacitance anyway, whether you take case A or case B, the capacitance increases by K times because of placing dielectric. Then what about V2? V2 would become V by K. And similarly, energy also will become E by K. So these cases are very important while solving the problems. I hope you understood both the cases. Now let us look at a sample problem based on this. So in the sample problem that we started solving, here a source of potential difference V is connected to the combination of two parallel plate capacitors. So this voltage V is connected when the switch is closed. So originally our switch was closed. So it was completely closed in this way. So once the switch was closed, what is the charge this fellow will acquire? The voltage this fellow will acquire is V. The voltage this fellow will acquire is V. Because it is in parallel to this. This is also in parallel to this. We can write E1 equals to half CV square, energy due to the first capacitor, plus half CV square. So we can get the value as half CV square plus half CV square. We get the energy of the first case as half CV square. Now, once we understood this, what we have done now, key K is opened and a dielectric of K is introduced. So for the given situation, so remember that the new situation is like this. Here we have voltage V. Here we have a capacitor of capacitance C, charge Q, and its voltage is V. Because as soon as we close the switch, the charge Q will become CV. Next, here again same thing. Here capacitance C, charge Q, and voltage V. Now the author is saying Now key K is opened. Now again the key K got opened. So this is voltage V. So I have opened the switch here. Now opened means there is no connection. Once we opened it, what did we do? And dielectric of dielectric constant 5 is introduced between the plates of the capacitor. So what we do is we introduce the dielectric between the plate of the capacitors. So it's dielectric constant, let me call K and K. Now he's asking the new energy in the system is E2. This is interesting. Why? Because whatever concepts we have discussed, that is connected to the source, not connected to the source, both of them are happening here. If you can see, if originally, if the energy is E, what would be the new energy here? This is connected to the source. We have seen it in the formula. When connected to the source, we get the energy is equals to K times E. So we can use the formula here. It would become, this energy would become K times, that is E1 would become K times E. This is not connected to anything. This is literally an isolated one. So the energy would become E by K. So what is final energy? E final is equals to E1 plus E2. So it would become KE. I think E1 and E2 already are being used to represent initial and final. I will write it as E1 dash and D2 dash. So E1 dash and D2 dash, that is KE plus E by K. The author is calling this as E2. So you can say E2 equals to, if you get E common, 1 plus 1 by K, K plus 1 by K. So E into, what is K value given? K value is given as 5. So I will write 5 plus 1 by 5. So E into 26 by 5. We know what is the energy stored in a capacitor, in a single capacitor, because that's how we did it, half CV square. So half CV square into 26 by 5. So you'll get 13 by 5 into CV square. Now I got my E1. Now I got my E2. So we want E1 by E2. So E1 we got CV square. E2 we got it as 13 by 5 CV square. So let us go for E1 by E2. E1 by E2 would be 5 by 13 CV square. Sorry, CV square would be cancelling out. We get the answer as C. I hope you understood how I solved this problem. The most important thing, to explain you everything step by step, it took so much time. Or else, as soon as I read the question, as soon as I realize that the switch is closed, this is how we are supposed to solve this in the examination. We know the switch is closed, so the voltage is V, voltage is V. So you will get half CV square plus half CV square, you will get it as CV square. Now, after that, we have removed the switch. Now we inserted a slab in this and inserted a slab in this. So E2 would become, this is like voltage connected to the source. Since voltage is connected to C, we will write K times half CV square for the first fellow. This is an isolated one. For an isolated one, the energy becomes 1 by K times the original one. Okay. So if you get half CV square, you will get K plus 1 by K. So 5 plus 1 by 5. So you'll get 13 by 5 CV square, and we will get E1 by E2 equals to 5 by 13. So which would be option C. So the most important concept in this is what happens when you place a dielectric when source is connected, and what happens when you place a dielectric in an isolated situation. Both are very, very important. I hope you understood how to solve this problem. Thank you.